One of the great things about what we've learnt in 2020 is that when you bring people together, almost anything's possible. So with the onset of the pandemic and COVID-19, we realised that there was a chance that we wouldn't have enough ventilators in New South Wales. So we approached both industry partners and our university partners to say, what can we do? A call to arms, can we work together and come up with a solution where we can design and construct locally ventilators for use either in our system or for our neighbouring countries. So I think one of the really important things has been the collaboration that we've had with some of the state's most well-respected and senior intensivists, so people that work in intensive care. And what we've found there is that they are completely supportive of where we're up to, and they have worked through our communities of practice with New South Wales Health to ensure that what we are producing will be approved for use as required. It's been incredibly exciting and a privilege to run this project on behalf of New South Wales Health, and to come up with outcomes in such a short period of time. The acceleration of this research and development has been extraordinary and only possible through people's goodwill and their knowledge and understanding and the professionalism. We've come up with some great solutions, and I'm really proud to lead in that space.
Firstly, I just want to say I'm very privileged to be able to collaborate with New South Wales Health, and particularly health infrastructure, with industry partners and with our university at large to actually help manage the COVID-19 pandemic. My role has been helping link both biomedical engineering and our clinical academics to actually work on a prototype through a rapid development process so that we help manage the COVID situation. So the first thing we did was, I've known Professor Greg Swanning for some time, and so contacted him and then arranged through contacts at Westmead Hospital, Nepean Hospital and Royal North Shore Hospital, experts in intensive care and respiratory medicine. We developed a team which actually moved forwards on using an older 1990s ventilator, but actually modifying it with today's rapid prototyping principles to develop a ventilator such as you see here today, which actually can be used in traditional hospitals or in out in the field, so where it's a makeshift health facility. So New South Wales Health Infrastructure has embarked on a project looking at various ventilator designs, and have come up with funding and resourcing to the Covida and another one from Newcastle, the Ventisys. So these two ventilators provide a suite of solutions for people that would need ventilator support from the COVID-19 pandemic. This one has the advantage of being able to be used in the field as well as the traditional hospital network. The Ventisys, which is more complex and can do a much greater range of ventilator needs, is used in the traditional hospital setting.
So these handles are to rapidly move this device around. The whole idea of this particular device is to be in an emergency situation such as a field hospital, and be able to transport people from one place to another and take them to medical imaging or to surgery, etc., and be able to continue their ventilation on a battery throughout the hospital. And then when they go back to their ward, they plug it into the wall and it runs off of the mains power.
My name is Daniel Landro, a current student here at the University of Sydney. I'm studying a combined degree in a Bachelor of Biomedical Engineering and Medical Science, and currently am in my 5th and final year. So back in mid-March, COVID was taking the world by storm. We only had to look at cities such as Wuhan in China and Lombardy in Italy to see how such high volumes of COVID-19 cases can cripple even the most sophisticated of healthcare systems. In Australia, at that time, case numbers were increasing at an alarming rate, and we knew we had to prepare for the worst case situation. So when Professor Greg Swanning, head of the School of Biomedical Engineering at the University of Sydney, reached out to his past and present students, in a call to arms, us engineering students knew it was time to do our part to help get through this crisis. Students from across the faculty and other faculties such as architecture and the business school came together and did their part, working in different teams within the project. I myself was involved in the mechanical engineering components of the project and worked to reverse engineer existing ventilator designs and engage local New South Wales manufacturers, as well as the high-tech facilities we have here on campus, such as the computer-aided manufacturing facilities, as well as the 3D printing technologies, to rapidly prototype parts and put together a prototype solution. There were over 550 University of Sydney students who contributed significant time to this project. In the month of April, students were putting in about 3 hours a day, if not more, into computer-aided modelling, contacting industry representatives from across New South Wales to source parts and components and to really get this project off the ground. This project was a deep dive into a real clinical public health issue and challenged many lessons that I've learnt throughout my 5 years at university. It definitely challenged my capacity for leadership, for project management and problem solving, and also reaffirmed my desire to make a difference as a biomedical engineer. I'm really proud of all the efforts that our team put together in addressing this crisis and have definitely learnt a lot from the experience.
AMP Control is immensely proud to be part of the Ventilator Innovation Project. I would like to thank the New South Wales Government, Health Infrastructure, the University of Newcastle, the John Hunter Hospital and all our associated partners. What this project has shown is what can be achieved when there is collaboration and strong partnerships between government, university and industry. The capability and ingenuity of Australian manufacturing and our skilled workforce is truly incredible. To go from our prototype unit in 11 days to our functioning unit in a matter of weeks to a fully world-class unit in a matter of months that is now fully scalable and manufacturable is truly an amazing thing. We do some great things in Australia, and if government, education and industry continue to work together, we can build a very solid foundation in industry.
So I was originally tasked with assisting to build the power supply system for the ventilator, which involved coordinating the battery, the actual power supply and the management of that system. And from there, it grew into assisting with procurement and then assembly of the unit and just running around and helping people get the project done.